All right, section 10.3 talks about displaying data, part 2, and we'll talk a little bit about line graphs. So it says a graphical form used to present related sets of numerical data is called a line graph or a broken line graph. Line graph may show the trend of a variable over time. Time is usually marked on the horizontal axis, with the variable being considered marked on the vertical axis. As an example seen in figure 19, Santa's weight over 9 years, is predicted. Observe that consecutive data points are connected by line segments. Okay. So here's her weight, right? We're talking about her age in years. So from 0, it looks like we're going up to 10 years, and her weight in pounds. And this is just a normal type of graph, right? This is something that can be expected. Let's see. So the next part here, we have a line graph. We're going to see if we can figure out how to answer some of these questions. It says the graph shows how the value of a car depreciates each year. So depreciates, guys, means it's going down in value. And if you look at the graph is going down as I read it from the left to the right. This graph helps to find the trade-in value of a car for each 5 years. The percents given in the graph are based on the selling price of the new car. Complete parts A through D below. Okay. So part A says, what is the approximate trade-in value of a $13,000 car after 1 year? Okay, so if we go to 1 year, we go over here, we go to the left. Oh, come on, pen. Let's try this one more time. There we go. We go to the left. Why is this not? Sorry, guys, my pen is acting up again. There we go. Okay, looks like we're about 70%. Okay. So for part A, we're going to find 70% of 13,000. So 70% would be 0.70 times 13,000. So I'm going to grab my calculator again, turn it on, 0.70 times 13,000. And for part A, I'm coming up with $9,100, okay? So that would be the trade-in value of a $13,000 car after a year. Okay. Part B says, how much has a $25,000 car depreciated after 4 years? Okay, so we go here to 4 years, and I go over to the left. So this is 20, let's see, this would be 30 right here in the middle. So this would probably be about 35%, okay? So I'm going to find 35% of 25,000. So 0.35 times 25,000. Okay. So let me grab my calculator again and see what's 0.35 times 25,000. Okay. And I'm coming up with 8,750, right? But this here would be the trade-in value, right? It's asking me how much has it gone down in value. So to actually answer part B, what I need to do is I need to take 25,000, not 2,500, but 25,000, and subtract 8,750 to figure out how much it's gone down. So 25,000 minus the answer that we got, which was 8,750, is going to give me $16,250. Okay, so 16,250 is actually how much it's gone down, right? Okay. Okay, let's see. Part C says, what's the approximate trade-in value after 10 years, or after 5 years? So if I go here to 5, that's 30%, okay? So 30% of 10,000, okay? So let me grab my calculator again. 0.30 times 10,000 is 3,000. Okay. Here's my trade-in value. And then, excuse me, part D. So let me clean up some of this mess that's here. Okay. And let's look at part D. Part D says, Danny wants to trade in her car before it loses half its value. When should she do this? Well, at the 50% mark would be right here. So I would say before 2 years, right? Before 2 years would be the time to do that. Okay, maybe 2.5, but definitely before 2 years. Okay. All right, so let's take a look here. It says the sales figures for a company are shown in the line graph. Which month in 2009 had the highest sales? Okay, so this is pretty straightforward, right? 2009 is the red line graph, and the highest sales would be right here, which would be in month 12. Wouldn't that be December? Our 12th month? Okay. All right. The next thing we have here are scatter plots. So it says sometimes the relationship between variables cannot be easily depicted by any type of a line. Frequently, a scatter plot is used. Figure 21 shows a scatter plot depicting the relationship between the number of hours studied and the quiz scores. The highest score is a 10, and the lowest score is a 1. So it says in a scatter plot like that in figure 21, we try to discern a pattern. In this case, it appears that the more hours that you study, the higher the quiz score, right? So again, if you just kind of look at this here, these are the number of hours studied. So if you start looking over here, look at where those quiz scores are, right? They are in that range, at least above an 8 or higher, right? And the less hours, then the lower the score, right? Okay. So it says consider the sequence of formed using the following recursive formula. The first term is -10, and thereafter each term is 4 more than the previous term. It says construct a table of values for this recursive relation, draw a scatter plot for the relation with a trend line, and identify by formula the best trend line for the data. Okay, so let's do that. Okay, so in doing this one here, guys, we're going to do this like we used to do our arithmetic sequences that we did in, I think it was 8.1. So remember, my first term here is -10, right? And then remember the formula, it's going to say A1 plus n minus 1 times D. Okay, so AN is going to be A1, which was a -10, plus n minus 1. It says each term is 4 more than the previous term. So my difference is going to be a +4. Okay. So I'm going to say -10, and I'm going to go ahead and multiply this out. And let's see, that's going to give me a 4n minus 4. So this will be a 4n, a -10 and a -4 would be a -14. Okay. So what I've actually done here, right here, guys, I've actually done part C first. That's okay. So it says construct table of values for the recursive relation. Let's go ahead and do part A. So A1 is going to be -10. A2, we're going to have -10 plus 4, -6. A3, we're going to have -6 plus 4, -2. A4, we're going to have -2 plus 4, +2. So on and so forth, okay? Now it says draw a scatter plot for the relation with the trend line. Okay, so we can do part B. You know what, I'm going to do it in red. Part B. I'm going to do this. And right here I'm going to put the term. So 1, 2, 3, 4, say 5. And you know what, because we're starting off on the negative, let me fix this. I didn't even think about that. But I'm starting off with a negative values. So let's do something like this. Like this. 1, 2, 3, 4, 5. And here I'm going to go by twos. -2, -4, -6, -8, -10, say a +2. Okay. And so we know the first term is right here at -10. The second term is over here at -6. The third term is here at -2. And the fourth term here is at +2, right? And my trend line is going to look something like that. Okay. And then again, this was part C. Okay. All right. So look at the next problem here. It says, what type of association exists for this data? Is there an identifiable trend? And if so, sketch it. So what I'm doing here, I'm looking at this data, right? Looking at these points. This is what we call a scatter plot. There are points kind of all over the place. But if you look at those points, as I go from the left to the right, wouldn't you say these points are going down for the most part? So I might have a line that looks something like this, right? Because those points are kind of lined up going down. I mean, they're kind of, it's not going to be perfect, but again, this is going to be the idea, right? Now, if I look at this one here, this is sort of all over the place, right? So I would say there is no association for this one, okay? All right. So look at the next part here. It says if a trend line has an equation y equals 12x plus 0.3, what type of association would you expect the data to have? Okay, let's think about this for a minute. Let me get my pen working again. It's freezing up. There we go. Okay, so think about this. Remember when we did our y equals mx plus b, and m stood for the slope, right? If I were to do a stare and compare here with this one and this one, wouldn't my m be 12, right? And if I was thinking about the rise over the run, I could think about it as 12 over 1. But the point is I know my slope is 12. And because 12 is positive, oops, this is going to have an upward trend, okay? Because I have a positive slope, right? And if I do the same thing for this next problem here, y equals mx plus b, right? And I do a little stare and compare here, and I see that my m in this case is a -5, or I think about a -5 over 1. In either case, the fact is that this slope is negative. So this here would have a downward trend, okay, because we got a negative slope. So positive here, and negative there, right? Okay, so now let's take a look at this next problem here. It says, what is wrong with the line graph? Okay, so first thing I want you to notice is, remember, this is my, let me get my pen here. This is my horizontal axis, and this here is my vertical axis, okay? So, part A says there's no label on the vertical axis. Well, there is actually, right? The frequency is here. So I know it can't be part A. Part B says there's no label on the horizontal axis, and the vertical axis does not have uniform spacing. So there is no label down here. That's correct. And does this have uniform spacing? No, it doesn't, because look, it goes from 1 to 2, jumps to 4, jumps to 8. So I would be going, okay, B seems to be a correct answer. All right. And part C says there's no title on that graph. That's correct as well. There's no label on the horizontal axis and the vertical, so I would go with C actually here, because not only do we not have a title, but we don't have a label on our horizontal axis, and the vertical axis does not have any uniform spacing. Okay. All right. So this next problem here says consider an arithmetic sequence with the first term 19 and the difference -1. Okay, plot this as a scatter plot. Okay. All right, so let's do this. my first term is going to be 19. My second term is going to be 19 plus a negative 1, which is 18. My third term is going to be 18 plus another negative 1, which is 17. My fourth term will be 17 plus another negative 1, which would be 16, so on and so forth, right? Okay, so it says plot this sequence as a scatter plot. So I'm going to draw my number line looking like this, and I'm going to go 1, 2, 3, 4, and I got to go all the way up to 19 at least, right? Okay, so let me see if I can do this nice and neat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There we go. Okay, so the first term is up here at 19. 18, oops, 19 is there. Number 2 is going to be 18. Number 3 is going to be 17 and 16. And my sketching the line is going to look something like this. Okay. And now we're going to find our equation. So remember, my formula is going to be equal to A1 plus n minus 1 times d. Okay. A1 we know is 19. N minus 1 times the difference is a negative 1. Okay. So I'm going to multiply this here. I'll leave that 19 alone. Negative 1n. Negative 1 times another negative 1 is a positive 1. Okay. And that's going to be a negative 1n. 19 plus 1 more would give me 20. Okay. And that right there, guys, is 10.3.